Hello, everyone. Good afternoon. I hope I'm able to go through this in the short time I have. My name is Abdulmateen Tairu. You can call me Tairu. And I'm here to talk about little ways that we stress our systems. How many of us here are like backend engineers or have built backend systems before? Yeah. So before I proceed, I want to mention one thing. In a team of engineers, who are the people you used to beef with the most? Do you have anything to mention? Who do you beef with the most? Back end. Ah. For me, my biggest beef is with UI UX designers. And I'll tell you why very soon. So why am I speaking about this? So I've built different systems for about 6 to 7 years, and there are a couple of issues that I've seen. There are a couple of times I've fought with designers or product managers or different things because it will kill performance. And I've also seen several systems that have like some anti-patterns that slowly slow down the system. So when the servers get stressed, so servers are like our computers. They have RAM, they have CPU too. You could use 90% or 95% of your CPU by writing the wrong code. You could have timeouts, you could have failures because of the creepy code you have written. In fact, if you have auto scaling, you could get high amount of cost, or if you are using what is it called this thing, serverless systems. So you won't want to build something that will make you run broke. So yeah, these are 6 anti-patterns that I have. There are many more that actually stresses your server. One of them is long request cycles. I'm sure we all use the internet, right? There are certain websites where they will tell you to upload a file or they will tell you to upload certain things. You'll notice that they don't do it immediately you ask for it. They will tell you, oh, we are processing it, and they have responded to you. That's actually how you should build systems like that. You shouldn't have like long running requests running in the request response cycle because there are huge amount of problems with that. If you use Chrome, just me going more deep. If you use Google Chrome only keeps 6 connections at a time. Imagine having 10 long running requests at the same time. You notice that some of it will have to wait for some. So that's the reason why you should not have things like that. So one way that people actually fix things like this is by using background workers. I know a couple of us will be familiar with background workers. Python people should know Celery. So you move it to Celery, let Celery do the work. So you notice this one example. If you are going to do fetch data, create PDF, upload to S3, it could take 10 seconds. 10 seconds is a lot of time for backend engineers. But if you move it to a background worker, it makes it very fast, 50 milliseconds. Now, to the one that makes me hate UI UX engineers is this one, pagination. I'm sure if you go to google.com, if you scroll down, you see 1, 2, 3, 1,000. And what is the usual way everyone builds this thing? Offset, page. It works. But imagine having millions of data in the database and you're showing page, I don't know, 10,000, and someone now clicks page 9,000. Let me tell you what happens in the system. The database actually returns all the data from the beginning till the end you asked for, then only returns you the last 100. Do you know how long that would be? Do you know how stressful that would be? Now imagine 10,000 users all calling that page. So definitely there would be problems. So anytime I see something like this and I'm to build it, first thing I do is I ask the designer, why? Why do we need to do this? Like explain to me. If there is no product need to do this, please remove it. Because you are just going to stress us. So how are you meant to solve this? There's something they call causal-based pagination. So basically, you could use anything. You could use maybe the time it was created or they call it sequential field. So I'm sure you might have heard of one argument of ULEAD, or they will say, should I use UUID for my foreign keys, or should I use normal sequential? So the reason why we have arguments like that is for something like this. UUIDs are very random, so you cannot really order it by that. Sequentials are not random. So people try to come to this middle ground and they use ULIDs, ULIDs. So you can use one field and you can order it by that. Then you can either use there's something they call infinite scroll for the front end guys. That if you scroll to the end, after some time it will load the extra data. So it will you just tell them, okay, oh, I fetch everything. Give me the next 100 data from here. I fetch everything. Give me the next data from here. So that's one thing that you can use to solve that one. So the third one is something they call N+1 queries. Django people, I'm sure you know this one probably. So N+1 queries is more of like if you have like a database of, let's say, posts, and you fetch all of it, and you now want to access the authors in each of it, you have done one query, you are still doing another query. So that's like, it makes it very, very, very slow. So in Django, there is something they call select related. There's also prefetch selected, right? Yeah, prefetch related, sorry. So those things like help you to like join the database and fetch it once. I know there are also alternatives in other languages like SQLize and so on and so forth. But the idea is the same thing. So because of time, I'll run through this one. The next one is counts. And I'm sure many of us are guilty with this one. You have a, back to my beef with front end, I mean with UI designers. They will design a dashboard and they have 20 statistics there. And you as a backend, what you are doing is you query and you do dot count. That is crazy, not going to lie to you. Imagine having a dashboard showing the count of the users and you have 1 million users. What you are doing is you are searching the whole database for that 1 million users just to return one number, 1 million. And imagine you have 1,000 admins. Your backend will just die. Like you are just stressing it. So there are a couple of ways to like solve this problem. Some people use what they call caching. I'm not really a fan of this one, but caching is more of like you have a cache and they have a cron job or something that maybe runs every 5 minutes. Every 5 minutes, count the amount of users and update that cache. Still doesn't make sense to me, but depending on your product needs, it will make sense. You can using it for users is wild to me, Sha. Next one that they use to solve this is something they call statistics table. I think this is the first thing I ever did out when I found out that okay, this is a real problem. So you have a whole table that holds statistics, and every single time there is a new addition, you update it. Every single time there's a removal, you update it. But if you don't write this thing properly, you run into something they call race conditions. If two people create something at the same time, it will update it by one instead of two. There's no time to explain that one, but that's one other problem that you could run into. So people could have, yeah, I already mentioned that one. You could use signals, that's what this is. You can either use signals to increment it all the time, or you could run the job actually to update it all the time. The third one is something they call materialized views. This might be a bit complex for some people. So basically, you could create something they call materialized views on the DB, and it only works for Postgres apparently, where you just have, that's what you call it, a materialized view, more of like an extra table that has these queries continues that continuously runs on its own. So what you just need to do is refresh it, and when you want to fetch the new statistics, you just fetch it. That's what you have here. Yeah. You just fetch it and you have the data. So you don't have to be calling, you don't have to be updating it every single time. You can just have a cron that runs every hour that refresh the stats, and that's all. I think this is my favorite way of doing it, but it's also complex too. Um, yeah, these are like the comparisons of all the ones I mentioned, and based on this, you just have to pick your poison, pick your struggle. Next one, fat payloads. How do I approach this? First of all, let's start with the responses. So we build backend systems, and I think a couple of us might be lazy while doing it. Someone just wants to return user details, so you just fetch user details and just return everything. That's all. You don't have energy. This one wants something, just fetch it and return it. It it sounds simple, right? But you need to remember that if you are doing things like this, You are storing stores on your RAM. Your RAM is getting occupied, even if it is small data. And always remember, imagine 1 million users using it. That 1 KB can turn to gigabytes. And now your RAM is full and your server will crash. So you have to, if you are getting data, right, always get what you just need. Or use serializers. Get what you need. Don't fetch everything. There is include, right? Yeah, when you're fetching data, there's only, yeah. You just fetch what you need and use it. Don't kill your RAM. You just need small data. You just want to check if a user exists. Why are you fetching the whole user details? Just get the ID and email. That's all. That's one. And another thing that happens again is you want to return image and you're returning base 64. Do you know how big it is? Who do you want to kill? Why? What is it? So like just push it to maybe an S3 bucket or anything and get the URL and return that. So the goal is like try as much as possible to not process huge amount of data at a time. Try to reduce it. Don't return it. Don't collect it. Now this is the collecting part. So I've once built a system where initially the product was just like the input was small data. Then later on they wanted to now grow it to collecting files, and they didn't want to build a whole new thing as a whole. So they said, okay, well, let's take the input base 64. I mean, it was easy, right? 20 KB data is fine, 30 KB data is fine. Then now they had to process one long PDF or something, 20 MB, and everything is breaking. Why? They are trying to pass huge amounts of, like, you can imagine how much 20 MB is in base 64. It's a long amount of strings. Like, if I write it down here, it will not, there will still be extra strings to write. So if you are sending that to any system, it could crash. That's one. Number two, you might have a system that maybe processes maybe a CSV file. Maybe you're trying to, like this one now, maybe you're trying to add, maybe, yeah, you're trying to create every single user from a CSV file. Maybe you were testing it with 20 users, it was fine. Now they give you 10,000 users and your endpoint is taking 2 minutes to run. So things like that, you should always try to avoid it. So one, do not take um, base 64, as I mentioned, or huge payload. If it is huge payload, just let the client side push it to S3 and send you a link. Then the front end person should just take the link and process it. Or they should just upload a file like this one is. Just get the file and process it. And if you are processing it, don't process this in the request response cycle, like we mentioned in number one. Just push it to a background queue and process it. So, to the last one, this one is something I'm very guilty of. There was a time I started learning about risk conditions. And if you have worked on financial applications, that thing can run you into debt. So I was like, well, I don't care. Maybe the server died. I sure don't want to lose money. For server to crash is better than for me to run into loss. So I started doing database row locking. Now I want to process 100 payments. I'll now lock a row for every single 100 payments. How can I explain this in the most basics of level? So imagine you have one, let's say a board here now, and two people read from the board. They go there to go and do something and they come back. Let's say the person comes and says, oh, there's one, number one is here. I want to go there, come back and add one extra to what I saw before. Now, one will walk there, will come back, will say, oh, I remember I saw one. I'll add one to what I saw before to write two. The other person will come back and say, oh, I remember I saw one. It will add one to what he had and say, and he'll write two. Meanwhile, what is meant to happen is two, then three. So that's risk conditions. You have two things doing the same thing at the same time. So row locking is like, if one person reads from it, nobody else will be able to read from it until I'm done. So I log the row to process one payment. So until it's done, before I unlock it. It's fun, right? But something like this actually stresses the DB, not even my server, the DB server. And if you have so many row lockings, there's something they call connection exhaustion. Your DB shall be tired and it will just drop any connection it has with you that don't stress me. Bye bye. So things like this actually stress the DB, having multiple locks because you don't want to risk conditions. So that's why there is something they call optimistic locking. Well, there are two ways to solve this, but one of it I mentioned here is reducing your concurrencies. Instead of just allowing multiple concurrencies to run at the same time, you can limit it to maybe 10 at a time. And this doesn't only go with database rule locking. It could be normal background works you are doing before. You cannot be processing 100 things at the same time. If an extra one comes, you now process 101 things at the same time. You should have a limit. Reduce it. Okay, I can only process 10 at a time. When I'm done with 10, I process the next 10, I process the next 10. Don't care what your users say. Better keep your system awake. Now, why you go transfer from UBA sometimes, it will take 10 minutes because there are still so many things in their backlog that they are trying to process. And yeah, the second one is optimistic locking. So yeah, optimistic locking is majorly like you have a version in your head. Using that example that I used the last time, the person that went with one in his head is coming back to update to two. Is optimistic is like, oh, I know I had one there before. Before I update it to two, I need to check if it is still one. If it is no longer one, if I see that someone else has updated it, I'll just fail. And what makes this thing very easy to even work with is the fact that databases only update a row one at a time. You can't have two things updating it at a time. Like it's one at a time. If two requests come in, to process one before the other. So you are sure that only one thing is updating it to two. So if one person updates it to two, the other person comes and sees two there, it's going to fail. So that's optimistic locking. So you don't need to lock the database. The database does not need to do anything. So yeah, those are the two differences here between optimistic and pessimistic locking. Yeah. Yeah, I know this was a bit difficult to take into the head at one time because performance is a very, what do you used to call it? It depends thing. Like none of this just goes as it is. There are sometimes you would need offsets. There are sometimes you won't need offsets. There are sometimes you will need to do every single thing here. There are sometimes you will need to do it and when you don't need to do it. But like it's always good to just have this checklist in your head to just prevent things like you don't want to have long running queues. You don't want to have huge payloads. You don't want to lock multiple rows at a time. You want to catch every um, compute data, like your count, your statistics. You don't want to be doing it every single time. So like it's just good to just have these things in your head. Okay, is my system having all of these things? If it is not, okay, then I have a good system. So yeah, this is just random stuffs, just like random English here. Performance is systemic, cannot just code deep. It's your whole system that determines how performance your system will be. Your server is just doing its best. Just let it breathe. Don't kill it. People always assume that okay, it's code, it will work. It's stressing the DB, it's stressing the server. And what do people do when they are stressed? They'll crash. Exactly. So that's what your server will do. Your server is like a human being. And yeah, also have empathy for your server, not only users. Your infrastructure too. It has its mind on its own. So yeah, if anyone has questions, I don't mind.